is G of dA, say, is delta D on G half of A. In other words, maybe this G is a gauge variation of some local function. Then you'll get delta U, delta B minus delta B, delta U on that local functional, and it will just tell you that the commutator of delta U and delta B is just G of those commutations, or G of the commutator of U and B. What is a local functional? It means the same as an action. It's the integral. Everything is at the same point instead of at two different points. But this is not, let's see, it's not the most general thing. Some solutions to that star equation way over there are not gauge variations. If there exists a solution that is not delta D of some G half, then we have an anomaly. Then we have a bona fide anomaly. The star relations are called the West-Zumino consistency. So just off in just the West-Zumino condition. So one such solution is that G of dA is equal to the integral over some manifold of dx to n of this omega 1 thing, of this non-abelian anomaly structure, and you can show, which I won't do here, but I'm happy to let people see the arithmetic unless they make you do it as a homework, that if delta U of this thing minus delta D of the same thing with U and D switched is indeed equal to G of this commutator of A. Where G now, maybe I should call this G tilde because it's confusing. So in other words, one solution is the variation of some local function. Another solution is this thing. This is not the variation of a local functional. This is a local functional, but it's not the variation of something. So if you do the variation of this and subtract it with U and V, you can show by, in my view, about 4 lines of manipulation that you get a commutator in here, or rather a commutator in there. And so the non-abelian anomaly obeys the West-Zumino consistency condition. And in fact, non-abelian anomalies are basically the non-trivial solution to the West-Zumino condition. They have to obey them. So I think I will stop here since we did a lot today, and I know I suppressed a lot of arithmetic. But that is basically what we've done here, is showing the topological structure, the connection between the abelian and the non-abelian anomalies, and then pointed out in this last 10 minutes that non-abelian anomalies are the non-trivial solutions to this equation. So they are, and all of this stuff is is standard in gauge theory, but it emerged, we have residuals of this all the time. Chern-Simons gravity theory, Chern-Simons gauge theories, string theory introduces these kinds of terms from various dimensions according to the conditions you want to have, and so on. So this is where they do it. This is where, yeah. Pardon me? To my knowledge, yes, I think so. It's either variations of something or that. So this is kind of reminiscent of the cohomology problem, and there is a gauge cohomology thing, right? We want all the solutions to that kind of equation that are not themselves variations. So this is not the gauge variation of something. Yeah. I guess we do that. The anomaly is false. Remember, there's 2n minus 1. So the variation of abelian is E of the non-abelian. But the integral of non-abelian is the solution to that. If you like, the non-abelian is the solution to that thing. That's not the thing. Subtle distinction that can get confused. Just like yeah. どうもありがとうございました。ありがとうございました。僕は去年はですね、ストップということについてとして27時間やらせていただきました。 Well, you do in some way, yeah. And you can, a Chern-Simons gauge theory arose by saying, okay, for a normal gauge theory, we get this anomaly, but now let's forget about where it came from and just construct the gauge theory made out of it and see what it does. And it turns out it has rather interesting properties. In part, those properties are connected with these topological things, but when you look at the functional integral, you find there's quantization of certain parameters due to these topological properties. So yeah, 2 plus 1 gravity is a kind of Chern-Simons gauge theory, and there are higher dimensional versions of all those gravity theories that I think O'Leah, other people, O'Leah and collaborators worked out the South American possibility. But basically there are